Hello, everyone. My name is Bruno Sanchez, and I'm the Planetary Computer Program Director. And I'm thrilled to be with you all here in Building the Future in the session of inspiration. Today, I will be speaking about the work we are doing with the Planetary Computer. But more than that, I will try to inspire, like the session says, of the the things we could do or the things we should do. Today, we are facing a set of problems or challenges at a planetary scale. Things like carbon, we are emitting a lot of carbon, which is driving climate change with effects in nature itself, but also in the effects in our capacity to do our lives. Our socioeconomic systems are deeply affected by the emissions of carbon. And we have basically 400 gigatons of carbon remaining to emit before the worst effects are seen. And at the current rate, it will be done in 7 years. So we have to change in that sense. We have a problem with that. We also live in a world that 1/3 of the people live in water-stressed places. It will be one half of the people on 2050. We also live in a world where we generate a lot of waste, 2 billion tons a year of waste, and most of it is not recycled, or we can't reduce the waste we emit, and we can't recycle the ones we cannot reduce. And we also live in a world that 25% of the species are threatened. So we have issues at the planetary scale. We should also fix, and we need to do that. And at the end of the day, a big question we are facing as society is like carbon, like water, like waste, like all the ecosystems I was just sharing, is what is where, how much is there, and how fast is it changing? This was basically an impossible question to ask in the past, because the world was too big, the data was too hard to process, and we just didn't know. Maybe we knew locally in our cities, in our region, maybe in our countries, but to know at the planetary scale what is where and how much is there, how many forests we have, how many schools we have, how many ports we have, how many trees we have, all of those things was basically impossible. Now it's hard to do, but it's possible to do. And the whole point of my talk is that what was impossible before today is possible, and it's becoming easier and easier. And that's the planetary computer we are building. But let's not get too much ahead of ourselves. Once you know what is where, then you can ask what could be there, what should be there. Should we transform our forest into cities? We need places to live, but we also need nature. And only now we are realizing how much we depend on nature, not only for agriculture and production and food, but also for the health of the people. There's a very intimate relation of the health of the people and the health of ecosystems and health of cultures and their capacity to keep nature as it is. We are understanding those things now again, because before we were not able to even ask questions like what is in this forest, or what is the value in terms of species, in terms of diversity, or also in terms of capacity to deliver the things we need as a society. So if we are able to ask those questions, we are faced with then the existential question of how we can minimize the environmental footprint, but maximize the human benefits, or in general, maximize our experience in our lives. So we all want to have food, we all want to have transportation, we all want to have a good life. We all aspire to do more and more, and the world is seeing more and more people being able to do more and more. We have halved the poverty in the world since 2000, and we are getting better at that. But we need to do that without increasing also our environmental footprint. And we can do this. This is a matter of understanding our footprint and then minimizing it. That again, that general question I open with, that to know what's happening where and could be happening. There is also an expectation from society for all of us, for all of this generation, especially from the next generation, of all of you, those of you who are listening to this session are students, then you have an expectation to us, the ones who are working now, to solve this question, to know what we can do to understand the damage we're doing to the world, and what we can do to stop it and to reverse it. And the recent COP sessions and all the recent things that have been happening as just a reflection on how much more important addressing these issues is. So environmental sustainability is at the core of that question. It's at the core of a lot of the things we need to do. And I would argue very soon, everyone's job will be related to environmental sustainability. How is it affecting environmental sustainability? And we need to do that because there are things we need to do, like, I don't know, transportation or food, and has an impact, but how we can measure that impact on how our jobs help increase the sustainability. And here's the thing. Environmental sustainability is increasingly complicated. We have much more data. We have sensors. We have satellite images. We have artificial intelligence. We have the capacity to ask many more complex and nuisance questions. But it means that things are more complicated. But it's increasingly recognized as a critical dependency, as I just been speaking for the last 8 minutes. But there's also opportunities to do. There's opportunities to understand and to fix how we have our forests, our rivers, our coasts, our lands, our beaches. We have an opportunity to increase those. And this is in our benefit as much as also the benefit of nature. And we are just learning that all of this is interrelated. We cannot take care of people without taking care of nature, and we cannot take care of nature without taking care of people. As I was saying before, it's increasingly complicated with things like AI, data, analytics, and there are not many people who understand the intersections of all of this. So part of the future is to figure out how experts across domains can talk to each other for a common goal, in this case, environmental sustainability. As I mentioned before, it's increasingly recognized as a critical dependency and opportunity. Many of you know the Sustainable Development Goals, and if you look at the goals, there are many of these that are intimately related to sustainability, environmental sustainability. 15, land on lands; 14, life below water; 13, climate change action; 0 hunger, food production. There's all of these. I would argue all of these goals are related directly or indirectly to environmental sustainability. But it's not only about that. It's also the World Economic Forum report on global risk has ranked top risks by likelihood and impact. And in green, you can see that many of those are related to nature and biodiversity and environmental sustainability. So it is being recognized as important, not only by society through the Sustainable Development Goals and institutions like the World Bank, the United Nations, and civil society, but also by companies that are also realizing that extreme weather, climate actions, failure on acting to that are risks. For those of you who are also entrepreneurs in the house, it is an opportunity in the sense that there has been so much funding for companies and startups doing environmental sustainability. The Economist in August last year was saying that in climate tech, everything is hard. As I was saying, things are complicated, but everything that is except raising capital. There has been so much increase of funding for this. I want to go to the demo of the Planetary computer, but I wanted to spend a few minutes to say that it is that what we are doing in environmental sustainability is extremely important, and it's connected. It's not just saving nature; it's also saving ourselves. You hear about these things like rewilding, like bringing back to the state of how things were wild before human interaction, or you hear about it in the term of nature-based solutions that are actions to protect nature, but at the same time are solutions to the things we need to do, like food production, or protecting the coast, or protecting our environment, or things that are counterintuitive, like, for example, fishing. If you protect a land, a part of the oceans from fisheries, you might think you get less catchment because you are fishing in less places. But what science says is that when you protect the oceans, not only you're helping fish stock, but also the overflow, the extra fisheries, because you have those fish banks, means that you even have more benefit for fisheries, fish stocks, but also for helping climate change. So it's all around. It's all around what the benefits that we have when we do environmental sustainability. So we need everyone to do this. We need education, citizen scientists, local governments, consumers, data scientists, app developers, and we need data. We need infrastructure. We need APIs, and we need models to do all of these things. That's exactly what the Planetary Emitter is, and that's what we're doing. That's what Microsoft is doing. We are curating data, we are providing compute environments, we are training AI algorithms, we are deploying APIs to help developers do their code and understand what is where and what should be there and hosting applications. We've been doing this for a few years, for at least 5 years on AI for Earth. We have done more than 800 projects in 110 countries for what I mentioned before, putting together experts in different fields, experts in climate change with experts in AI, experts in cloud computing, and fueling innovation, inspiring through the example and inspiring through the latest research. As I've been trying to argue, we need to transform the way we do all of this. We need to transform the way we measure, we monitor, we model, and we manage Earth ecosystems. We need we need a open, global, across-domain, science-based analytics platform to do all of these things. And that's exactly what the Planetary Computer is. And we are so excited that this is not just plans. Last year, I was also here in this conference, and we were talking about the work we were doing before and the plans in the future that included the Planetary Computer. This year, I'm really happy to come back and tell you that we've done it. We've built it. It's available for all of you today. We have data like satellite data, like Landsat, Sentinel. We also have weather data. We have land cover data, biodiversity data, all the kinds of data that you need. We also have APIs, which is a way for computers so that you don't need to dig through millions of files to find the ones you need. You just ask the API what data you have for Portugal for summer 2020 when it's not cloudy, and the API will tell you so that you can start doing your work more efficiently. And as I mentioned before, you have the data, you have the APIs, and it's the place to do all of these computations. That is also something that the Planetary Computer helps you. It's a way for science to be done, to replicate the science, to share the science across all the stakeholders, NGOs, academia, but then also is the place to also operationalize all of this science into insights and to things that actually then companies and governments and all other stakeholders can actually do to then take action, not just measure things as they're happening. We're also building applications as I mentioned before, we have an application to measure what is the forest in the world, what is the urban in the world, what is the fire risk, how do you make all of these conservations. I wanted to jump in a few minutes we have left to show you that not only we have done a Planetary Computer, it's also available to all of you. So if you go to planetarycomputer.microsoft.com, you will see this page, and that's exactly what we said we would build. We have the data, we have the APIs, we have the computation environment, and we have the application. Just to go to some examples, let me just show you. If you go to the Explore way, let's just go, for example, to Lisbon, where we are, and say that we want to show the data for this. You went into almost the airport. That is good. Let's just show the data, satellite data. From, for example, the fall of 2021, you can choose any other region. You can choose the most recent ones. And what you're seeing here is the data coming from the satellite and then going into the cloud of Azure and then being streamed directly from that storage to you. This is no small feat, and this is something that Basic has not been able before to do. That the ability to see the latest images, like I'm showing here fall 2021, but I can go to last year, I can go to other places. And the goal here is that you not only have the ability to see the satellite data, you also have the code to start building solutions. And this is extremely powerful because then let's go to another in 2 minutes I have left. Let's go. If imagine you're working on energy access and you want to know how much light there is at night, what villages have light and what villages do not have light. So I can see that in 2021, I have all of this data. And if I then cross this data with my code to what are the villages, the people, where do people live in the world, I can start asking question of who has access to energy and who does not have access to energy. That's also what we aim to do here, not only with the visualizations I was just seeing here, we are also putting all of this as open source. All of this with open standards, all of this with open data, which means that we are maximizing the opportunities for anyone to then build applications. Like we have some examples here that I don't have time to go through, but I invite you to go to the website and take a look to that and the documentation, how to do all of things. Granted, this is still a technical platform for technical people to do their work. But what I think is revolutionary, what I hope inspires you, is that before all of these things were basically impossible to do, to measure, to see the latest satellite images, the latest images in a very open way, open source, open data. Now all of this is possible. So when we asked before in the beginning of my talk that we are facing challenges, how do we protect the coast, for example, or how do we make sure that people do have access to electricity or do have access to school, do have access to all of the resources they need, but also we measure what is the erosion of the coast and we can minimize that, what we can do to do that, how we can monitor, model with the latest science, and then deploy all of the solutions. It is possible to do that today. And with efforts like ours, what our hope is that we enable more and more skills by more and more people to actually take action, to have more environmental sustainability, and at the end of the day, do the thing I said at the beginning, to know where are things, what is there, what should be there, and what are our options to minimize our environmental footprint and maximize our experience. So I hope I was able to inspire you with the Planetary Computer. I am very sorry. I'm very much looking forward to see what you build with that. And with all that, please enjoy the rest of the conference and do feel free to reach out to me if you have questions, comments, or ideas on what to do with this. Thank you.